Okay, let's unpack this. We hear so much about AI, right?
Right.
Recognizing faces, driving cars. But what's really going on, like under the hood, we've got these sources you sent asking us to sort of demystify how these systems actually learn. So today, we're doing a deep dive, not just definitions, but tracing how raw data becomes, well, intelligence.
And what's really fascinating here is this shift, the fundamental change from how we used to think about programming.
Right.
Traditionally, you write the rules. If this, then that. Very explicit.
Like if it has pointy ears and fur, it's a cat.
Exactly. But then what about a Sphinx cat? No fur. Your rules break. Machine learning flips it. You don't provide rules, you provide data. Thousands of cat pictures, all labeled cat. And the computer, well, it learns the rules itself. It figures out what catness is from the examples. That's the core idea. Machines learning from experience, and for them, experience is data.
So it's like traditional is data plus rules equals answers.
Yep.
But machine learning is data plus the answers you already have equals the rules.
You got it. That's the reversal. The machine builds a model. It's learned rules. Think about a spam filter.
Okay.
You don't list bad words anymore. You just show it tons of emails already marked spam or not spam.
And it just figures it out.
It learns the patterns, what kinds of words, what phrases tend to show up in spam, and it keeps learning as spammers change tactics.
That's powerful. Solves things we could never write rules for, right? Like movie recommendations.
Exactly. Or finding subtle things in medical scans. And there are, broadly speaking, three main ways machines learn. Three main flavors.
Flavors. Okay.
First, supervised learning. This is where you have that labeled data like the cat pictures or spam emails. The teacher supervises by providing the right answers.
So it needs labels.
It needs labels.
Mhm.
Great for classification. Is this A or
Right.
B, spam or not spam, or regression predicting a number like a house price.
Okay, supervised. Got it. What's next?
Unsupervised learning. Now imagine you have data, but no labels, just stuff, like
Yeah.
a giant box of mixed logo bricks.
Okay, chaos.
Kind of. Unsupervised learning finds hidden structures in that chaos. It groups similar things together. That's clustering. Think grouping customers by buying habits.
Finding segments.
Right. Or finding surprising connections associations. That old story about people buying diapers and beer together.
Yeah.
That's association discovery.
Okay. And the third?
Reinforcement learning. This one feels maybe more intuitive. It learns by trial and error, like teaching a dog.
Treats and telling him off.
Sort of. An agent tries things in an environment. It gets rewards for good actions, punishments for bad ones. It learns strategies to maximize rewards over time.
Like game playing.
Exactly. Beating humans at complex games. Or robotics, teaching a robot to walk or pick things up. It learns through doing.
Wow. Okay. Supervised, unsupervised, reinforcement. Different tools for different jobs. But how does the learning bit actually work inside the model?
Great question. Let's stick with that house price prediction. A simple line, maybe. The model starts. Well, pretty dumb.
Right.
Random guesses. It makes a prediction, compares it to the actual price, and measures how wrong it is. That wrongness measure is the cost function.
Like an error score.
Precisely. Then it adjusts its internal knobs, weights, and bias just a tiny bit, trying to make that error score smaller next time.
So tiny course corrections over and over.
That's exactly it. The main method is called gradient descent. Imagine the error score as a hilly landscape. The model wants to find the bottom of the valley, the lowest error.
Right.
So it always takes a small step in the steepest downhill direction, again and again,
Until it finds the lowest point.
or close enough. But here's the critical part.
Yeah.
It needs to generalize. It shouldn't just memorize the houses it saw during training.
It needs to predict prices for new houses, ones it hasn't seen.
Exactly. That's intelligence. We use separate training data to teach it and testing data to see if it actually learned the underlying patterns or if it just memorized noise. That's avoiding overfitting.
Makes sense. And you see these ideas everywhere now. Recommendation engines must use a mix of these.
Oh, absolutely. Often blending supervised and unsupervised techniques. And think medical imaging, deep learning models, especially things called convolutional neural networks or CNNs.
Okay.
They're amazing at seeing patterns in images, like our visual cortex. They can spot tiny tumor signs doctors might miss. There, you really want high recall, find every potential case.
Right. Better safe than sorry.
And self-driving cars. It's a whole ecosystem.
Yeah.
CNNs identifying pedestrians, other models predicting paths, reinforcement learning making driving decisions.
Oh.
Even the large language models, like chatbots. At their core, they're incredibly sophisticated prediction engines, figuring out the most likely next word, based on all the text they've learned from.
So pulling this all together, understanding these basics really demystifies AI, doesn't it? It's not magic.
Not at all. It's built from these relatively simple blocks, different learning styles, optimization like gradient descent, and lots of data carefully prepared. It really is becoming a kind of foundational literacy.
Absolutely. So thinking about all this, what new problems could you, listening right now, imagine solving if you had a machine that could learn directly from data? Something to think about.